Moving into some more geometry, we're going to talk about curves, circles, and polygons. So let me start with on a pencil. There we go. So they start out with talking about curves. So curves, we know a little bit about curves. If we drive a car, we know curves are not straight. They kind of bend a little bit. So a curve can be defined as a line or path that bends instead of going straight. So for us, a lot of times a curve would look something like this, or like you're going and then you're turning and then you're going this way and then you're turning again. So you have, curves, if you will. So you're not going in a straight line per se. So a geometry definition of a curve is a set of connected points that form a shape that bend, turn, or loop rather than extending in a straight line. So it's kind of what we did. There's what's called a curve that's open or closed. So, and talk about open curve. An open curve does not start and end at the same point. So, if I kind of draw and then bend and bend again and bend again, if you like, just keep on going. Notice how I started and I turned and I turned and I turned, but I didn't get back to the same point. So, that would be what's called an open curve. Like we said, a curved road or the shape of a rainbow. So again, notice how a rainbow starts and finishes, but the start and finish are not at the same point. So that's what we call an open curve. A closed curve starts and ends at the same point and closes a region. So you can almost think of it like if you're thinking like Formula One, you have a racetrack going, you got to bend, got another straightaway, bend, straightaway, bend. But notice how you make a full loop, if you will. You get back to the same point. Or like NASCAR or something, you just have a simple like oval loop. You kind of go around and around and around, just all left turns. So, so a closed curve kind of encloses a region. It could be like a circle or oval, or it could be kind of something a little bit more involved, like getting back to the same point on a road. Now, another thing we have is what's called a simple curve. A simple curve does not cross itself. So again, a circle would be an example of a simple curve. It doesn't cross itself. So also, again, you could have said, this would be a simple curve because it doesn't cross itself. Okay, so it doesn't have to be touching back to itself. So a non-simple curve is something that actually crosses itself. So it's almost like a figure eight, if you will, crosses back over, something like that. So notice how the curve crosses back over itself. Or you can kind of do like where it doesn't actually have to touch again. So it kind of bends and comes around and doesn't finish back at the same point. So so the figure eight would be something or even like something to this effect. So it could be about anything, you could be bending, and then cross. So that would be a non-simple curve because it crosses itself. So we have that going on. So when it comes to the terminology, notice that these are simple curves, but this one's closed. This is a simple curve here, but notice how it doesn't come back to the same point, so it's not closed. Not simple, as we said earlier, not simple. So we have an open curve and a closed curve, and then we have simple and not simple. Not simple crosses itself. So notice how these are. not simple, but notice how it closes in a region. So these are not simple and closed. But notice how even that is actually considered it's not going in a straight line. So that's still considered a curve, even though it's bending, but it's bending sharper. So it can be like that. But now, not simple, not closed. Notice how we don't get back to the same point. We're kind of open-ended there. So stuff like this would be considered not simple and not closed. So again, not simple crosses itself, but simple does not cross itself. So more commonly in geometry, we're probably more used to the simple than the not simple. These shapes look a little bit more familiar than these shapes over on the end. So again, common curve examples in geometry, a circle, an arc, ellipse, parabola, and a spiral. So, a circle kind of does this, an arc kind of, it's like a circle, but it doesn't go back to itself. And ellipse is sometimes we call it more like an oval. A parabola kind of does this, and then a spiral kind of, to me, a spiral you kind of start in and you spiral out, keep spiraling out. To me, that's what a spiral is. So notice if you look at this, a circle would be simple and closed. An arc would be simple, not closed. An ellipse would be simple, closed. A parabola would be simple, not closed. And a spiral would be simple, not closed. Because notice how none of these don't cross themselves. When they cross, then that's considered not simple. So usually we're used to seeing curves like that.